Our next speaker is Neil Donahue. Neil is a professor of chemical engineering, chemistry, and engineering and public policy at Carnegie Mellon University. He's an active participant in the Science and Engineering Ambassadors Program in Pittsburgh with Emmanuel. So it'll be interesting to compare and contrast his experience as a tenured professor with Emmanuel's experience as a grad student. Neil.
Thanks. I'm going to upstage you guys, literally, not figuratively, I hope, but I like to stand up. Stage you folks. Sorry. I want to tell you a story. And it starts in May, actually it started before this, but in May 2016, we published a couple of papers in Nature. Yay! We like to do that, right? And they're well written, if I do say so myself. We spent a lot of time writing these, crafting these papers well, so they would be appropriate for the general scientific audience that reads Nature. And you see the titles, they're on climate change. This is May 2016. And at the Cloud Consortium in CERN, where we did this work, we studied the formation of fine particles in the atmosphere and focusing on the elementary physics and chemistry responsible for formation of particles, because they're one of the leading sources of uncertainty in climate forcing. And we have some experience in writing papers in Science and Nature, as you see on the bottom there. And in this particular case, we were looking at chemistry that produced fine particles from compounds that come out of trees. So this is presumably chemistry that's been going on for hundreds of thousands of years, long before humans were around and long before anthropogenic climate change was a significant issue on the planet. And so within a couple of days, this work was picked up by the editorial board of the Wall Street Journal and showed up in an editorial and inserted it directly into the presidential campaign, which was kind of a sobering experience. And let's look exactly at what they said here. So this research has yielded one certainty: a human impact is hard to disentangle from a welter of natural variables, the trees, right? New information based on actually measuring and understanding things like temperatures, emissions, and cloud formation is increasingly rewriting our hazy understanding of atmospheric processes. I love the word hazy. I mean, the rhetorical flourish there is pretty good. This data suggests our computer models have overstated the warming risk. Points off for data is a singular, these plural, but okay, so what do we actually do? This figure shows the IPCC best estimate for anthropogenic forcing from long-lived greenhouse gases since the beginning of the Industrial Revolution, and the various long-lived gas forcings on the colored stripes across the top, dominated by carbon dioxide. And we're very, very certain of that long-range forcing, so that bell curve grade distribution is quite narrow at a little more than 3 watts of additional heating per square meter of the surface area of the Earth. And in contrast, what we study is the effect of particles on clouds and direct scattering of light by particles, because that hazy understanding is much less certain. And they cause a cooling effect. And that distribution is shown here. And when you combine those, because of the enormous uncertainty from the aerosol climate effect, the total effect of human activity on climate forcing is quite uncertain, as shown by that distribution. So that's why we're doing what we're doing. What do we actually find? So this map shows that when a student, Hamish Gordon, at Leeds, put the new chemistry and physics that we had outlined and we had discovered into a global climate model called GLOMAP, this is what he found, and this is published in the Proceedings of the National Academy of Sciences again in 2016. So the blues are cooling, and this shows that putting all of this chemistry, including the emissions from trees, into GLOMAP, we get a total cooling of about an additional 0.6 of a watt per square meter. So what we actually saw in terms of the IPCC distribution is that blue arrow there. It's very, very clear. A little bit more cooling, but very well within the uncertainty range outlined by the IPCC. And if we take the trees out, we see a slight shift, a little bit more cooling. So we weren't disagreeing with anything. And this is an interesting issue, because we worked long and hard to debate it internally about whether we should pay attention to the public perception of what we were doing. And ultimately, the argument that we essentially shouldn't won out, and I was on the other side. But subsequent to that, we're working hard with Brooke Fischhoff, with Illa Norbosch, to engage communities in Pittsburgh around the questions about air pollution, because these particles are hazy pollution that kill 4 million people around the world every year. How we should do research that engages that question and the connections between these things, actually listening to public communities and using the Science and Engineering Ambassadors program as the vehicle to engage the public on the questions going forward. So thank you.
Thank you.